Today, we will learn about simplifying trigonometric expressions. Now, the main idea here is that when you're trying to simplify any kind of expression that involves trigonometric expressions, this strategy here is to try to rewrite everything in terms of sine and cosine. Just like explained here in the main idea, we will write every term in terms of sine and cosine. We will try to verify or also simplify. Or when we try to simplify or verify any kind of trig identities. So if you're trying to verify or if you're trying to simplify any kind of trig expression or identity, we will use the idea where we're going to try and rewrite everything in terms of sine and cosine. So let's get started. Now, our goal here is to write the expression in terms of sine and cosine and then simplify. Now, the first thing that you need to notice is how many expressions do you have here? How many trig expressions do we have here? Here we have two, cosine and cosecant. We need to write every single one of them in terms of sine and cosine. Notice that the first one, it's already written in terms of sine and cosine because it's cosine. So we're going to rewrite it. So we're going to have here cosine of theta times. So cosecant, we need to rewrite it in terms of sine and cosine. But remember your trig identities. We know that cosecant, that is equal to 1 over sine. So that means that we can replace cosecant with 1 over sine in our expression here. So now all we did is we rewrote the original expression in terms of sine and cosine. Now we multiply this. If it helps, you can remember there's an imaginary 1 there. So now we have cosine times 1, which is cosine. 1 times sine equals to sine. So now we have cosine divided by sine. And if you remember your trig identities, you will remember that this is equal to cotangent. Let's look at our next example here. So now notice that the second example here, we have cotangent and sine. We have two expressions. We are going to try and see if we can rewrite every single one of them in terms of sine and cosine. So here we have cotangent. Cotangent, if we look at our reference, cotangent, well, it's true that you can write as 1 over tangent, but that's not going to help us because we want to write everything in terms of sine and cosine. So I see that cotangent here, I can rewrite it as cosine over sine. So let's rewrite cotangent as cosine over sine. So we have cosine over sine times, notice that the second one, it's already written in terms of sine, so I'm just going to rewrite it. Sine of theta. So now what do you notice about the signs here? Well, if it helps you, you can put this over 1. Notice that the signs will cancel out. And now what we have is cosine. Well, let me rewrite that. It's going to be cosine over 1, which is just cosine. So that means that cotangent times sine, that's the same as to just write it as cosine. Let's look at our third example here. Again, all we're trying to do is rewrite everything in terms of sine and cosine. So let's look. Here's my first trigonometric expression, secant. Can I rewrite secant in terms of sine and cosine? I see that secant is 1 over cosine. So instead of writing secant, I can write 1 over cosine. So now we have 1 over cosine. So that's great. Cotangent, let's do that in a different color. Cotangent, I can rewrite it as cosine over sine. So now, instead of writing cotangent, I can write cosine over sine. So now we have cosine over sine. And sine, it's already in terms of sine, so we're just going to rewrite it. If it helps you, we can do sine over 1. Now, notice to see if anything cancels out. So I notice that this cosine is going to cancel out with this cosine. This sine is going to cancel out with this sine. So at the end, what we have here is 1 divided by 1, because if everything cancels out, the only thing that is remaining on the top is 1. So that's how I end up with here. Cosine and sine, that they cancel out, the only thing that is remaining is 1. But we know that 1 over 1 is just 1. All the problems are always going to be set up in such a way where you can cancel either cosines or sines after you rewrite each of those expressions. So now, let's look at our next example here. Let me pull our reference sheet. Here it is. Now, let's look at example 4 here. Notice that in the examples that we were working on, there was always just multiplication. I was just multiplying 2, so that's pretty straightforward. I was multiplying 2, so that's pretty straightforward. I was multiplying 3, so that was pretty straightforward. But notice that in this example, we're not multiplying, we're actually adding. So we got to think a little bit more at this time. But still, we're still going to use the same strategy. So cosecant, I can rewrite it as 1 over sine. I'm still using the same strategy here, which is try to rewrite everything in terms of sine and cosine. So now we're going to have 1 over sine plus 1. Well, we can rewrite that as 1 over 1. Oops, I'm sorry, 1 over 1. But notice that what we're doing here is we're adding two fractions. And you got to remember that there's a rule in mathematics that if you want to add fractions, they need to have the same denominator. So here your denominator is the trig function that you have on one of your fractions. Here my trig function is sine. So I need to multiply the right side, sine over sine. Because if I do that, notice that I'm going to have the left side has not changed at all. And then on top, I can write as sine over sine. Now that they have the same denominator, now I can add the numerators. So now we're going to have 1 plus sine all over sine. The strategy here was to rewrite everything in terms of sine and cosine. Any trig expression that you have here, we notice that cosecant was equal to 1 over sine, so I rewrote it. 1, you can write as 1 over 1. You're adding two fractions, they need to have the same denominator. So the right side, I multiply sine top and bottom. So if I do that, the denominators are going to be equal. And now I can add the numerators. 1 plus sine is 1 plus sine, equal denominator, which is sine. Let's look at our last example here. Cotangent. So let's see. Can I rewrite cotangent? I notice that cotangent is cosine over sine. So that means that cotangent square, that's going to be the same as cosine square over sine square plus 1. Instead of writing 1, I'm going to write 1 over 1. So notice, if you're adding two fractions, they need to have the same denominator. Notice that the right one, denominator is 1. I need to make it have the same denominator on the left side, so I need to multiply it by sine square, top and bottom. Now that we have that, we're going to have the first term does not change at all. So cosine over sine square. But now 1 times sine square is just sine square. And 1 times sine is sine square. Now that they have the same denominators, we can add the numerators. So now we're going to have cosine square times sine square all over sine square. So at this point, we can conclude here, because we have not talked about Pythagorean identities, but notice that in our next video or in our future lessons, there is a reference sheet that will tell you that cosine square plus sine square is equals to 1, but we have not seen that yet. This is called Pythagorean identity, but as of right now, we can stop here, but know that there's a Pythagorean identity. Whoops. That says that cosine square plus sine square that is equal to 1. We have not talked about this yet, so we can stop here. But now that I have talked about it, let's actually use it. So we can still simplify this, because thanks to the Pythagorean identity, now we know that cosine square plus sine square is equal to 1. So we can simplify this as 1 over sine square. Here's your entrance ticket. Try to simplify the following.